Hello everyone. Welcome to the fourth lecture on behavioral modeling. Myself R. Bhagyalakshmi, Assistant Professor, Department of EMC, Government Engineering College, Hassan. So, before getting into the topics of lecture 4, so let us review the topics what we have discussed in lecture 3. In lecture 3, we have discussed about the conditional statements using if and else. Also, we have studied about multi-way branching using case, case X and case Z statements. We have also studied about looping statements such as while, for, repeat, and forever. Also, we discussed examples regarding all these types of sequential statements. So now moving further with lecture 4, let us see the learning objectives of this lecture 4. In this lecture, we are going to define sequential and parallel blocks. We are going to understand naming of blocks and disabling of blocks, understand the nesting of blocks. So here, naming of blocks, disabling and nesting of blocks are the special features of blocks. And also we are going to discuss few examples on all these topics. So let's continue. There are two types of blocks in Verilog HDL, that is sequential blocks and parallel blocks. Now let us know in detail about the execution of statements within sequential blocks and parallel blocks. So first of all, let us begin with sequential blocks. The keywords begin and end are used to group statements into sequential blocks. It means if the execution of statements is to be sequential in nature, then we need to enclose them in between begin and end keywords. So if we enclose the statements in between begin and end, then they constitute a sequential block. Sequential block have the following characteristics. So which are they? The statements in a sequential block are processed in the order they are specified. So that is, the statements are executed in the order in which they are specified in the block. And a statement is executed only after its preceding statement completes its execution. Until and unless the preceding statement completes its execution, the next statement cannot be executed. The second characteristic is if delay or event control is specified in the sequential block of statements, then it is relative to the simulation time when the previous statement in the block will complete its execution. So, based on the delay that is specified with respect to each statement in the sequential block, then only the next statement will be executed in a sequential block. So, these are the features or characteristics of sequential block. Now, let us continue. Let us see an example with respect to sequential block. So, let us see illustration 1. Here, X and Y are declared as registers and Z and W are 2-bit registers. The keyword initial is used to enclose the set of statements here. Here, as we came to know just now, we are enclosing the sequential statements in between the keywords begin and end. So, all the statements which are written within begin and end are called as sequential statements, or the execution of the statements within the keywords begin and end are said to be sequential in nature. So here within begin and end we have four statements. First statement is x is equal to 1 bit binary 0. Second statement is associated with a delay of 5 time units. Y is equal to 1 bit binary 1. Third statement is associated with a delay of 10 time units. Z is equal to concatenation of X and Y. And fourth statement is associated with a delay of 20 time units, and W is assigned with the concatenation of Y and X. Now let us see what's the duration of time at which these statements complete their simulation. So since the first statement is not associated with any delay, it completes its simulation at time 0. Whereas coming to the second statement, since it is associated with a delay of 5 time units, so this statement will complete its execution at 5 time units. And similarly, the next statement. So here we need to see here that since the previous statement will always block the execution of the next successive statement, so this statement can only be executed after 10 plus 5, 15 simulation time units. Hence, until and unless this statement is executed, the next statement will not be executed. Hence, it will take a delay of 10 plus 5, 15 time units to complete its simulation. Coming to the last statement. So since it is associated with a delay of 20 time units and it will be blocked by the execution of the previous statements, which are associated with a delay of 10 plus 5, 15 time units. So this statement will complete its execution at 20 plus 15, so that is 35 time units. So in this way, the statements within the sequential block associated with delay will be executed. So let us move on to the next example. So here we have taken one more illustration of a sequential block where we have same four set of statements which we saw in the previous illustration 1. But here the statements are not associated with any delay. Hence, since the statements are not associated with any delay, so all the statements will begin their execution or begin their simulation at time 0 when compared to the previous illustration what we discussed with some time delay. So since all the statements were associated with some amount of time delay, here the statements are not associated with any time delay. Hence, the statements will be executed at 0 simulation time, one after the other. So let's move further with the next topic, that is parallel blocks. So we have come to know about the sequential blocks, where sequential block of statements will be written within the keywords begin and end, whereas the parallel block of statements must be enclosed in between fork and join. So here the keywords fork and join are used to model a parallel block of statements. The parallel blocks have the following characteristics. First one is statements in a parallel block are executed concurrently. Concurrently means at the same instant of time, parallelly. Ordering of the statements is controlled by the delay or event control associated with respect to each statement. So if at all the statements are associated with some delay, then the ordering of the statements will be controlled with respect to the delay or the event that is specified. So if delay or event control is specified, then it is relative to the time at which the block was entered. So it will not be the same case as it happened in sequential block. So now let us see an example with respect to parallel block. So here in this example, we have X and Y declared as registers and Z and W are declared as a 2-bit register. So we have considered the same example here, which we had considered for the sequential block. So for better understanding, here we can see that the statements are enclosed within the keywords fork and join, and hence the statements will constitute a parallel block. So here the first statement, X is equal to 1-bit binary 0, and then following statements are associated with a delay of 5, 10, and 20 time units respectively. So here, since it is a parallel block of statements, since the set of statements are enclosed between the keywords fork and join, so let us see what will be the simulation time at which each statement will complete its execution. So the first statement will complete its execution at 5 units of time, since it is associated with a delay of 5 time units. Coming to the next statement, since it is associated with a delay of 10 time units, it will complete its simulation time at 10 time units. Whereas, in contrast to sequential blocks, which the same statement will complete its execution at 15 units of time. So, whereas in a parallel block, it will complete its simulation at 10 time units. Coming to the last block, so which is associated with a delay of 20 time units, it will complete its simulation at time 20, whereas the same time was 35 time units in case of a sequential block, that is 20 plus 10 plus 5 is equal to 35. But here in parallel block, this statement completes its simulation at 20 time units. So this is how the statements will be executed in a parallel block. So here we have a pictorial representation of the waveforms with respect to the examples what we discussed just now. So this is a sequential block and this is a parallel block. So here in this example of sequential block, so which we came to know just now that, so the statements which are associated with delay here will always block the execution of the next successive statement. So since in sequential execution, the statements are executed in order. So here we can see that the first statement, y is equal to 1-bit binary 1. So y is updated to a value of 1 here, logic value 1 here. So at 5 time units. And also we can see that the value of the variable z, which is equal to concatenation of x comma y. So z, here we can observe the value of z. So it is updated to the new value after 10 time units. That is 10 plus 5, 15 time units. So the last statement, so it will complete its simulation by 35 time units. So this is the pictorial representation of the execution of statements in a sequential block. So similarly, if we consider the same set of statements enclosed within the keywords fork and join, which will constitute a parallel block, here we can see that the value of y is updated at 5 nanoseconds itself. So in both the examples, coming to the next statement, so which would be executed or completed its simulation at 15 time units. So here it is done at 10 time units. Whereas coming to the last statement, so we can observe that, so the last statement completes its simulation at 20 time units. Second statement at 10 time units, so that is the value of z is updated at 10 time units and the value of w is updated at 20 time units. So This is how the set of statements will be executed within the sequential block and a parallel block. Let's continue further with the limitations of parallel blocks. So, parallel blocks provide a mechanism to execute the statements in parallel. So since the statements are executed in parallel, so sometimes they may give rise to implicit race conditions. So that when two variables which are dependent on same data are executed at the same instant of time, then obviously it will lead to race condition. So, race conditions might arise if two statements that affect the same variable complete at the same instant of time. So, now let us see an example which will depict this race condition. Here we have chosen an example where set of statements are enclosed in between begin and end. Here it is in parallel execution. So we need to enclose the statements between fork and. Here we have four statements written within the parallel block. So here, since it is a parallel block, all the statements begin their simulation at time 0 and we don't know the order in which the statements are executed. So if at all x and y are executed at first, then z and w will get updated with the value of 0, 1 and 1, 0. If these two statements get executed at the last, then z and y will get the value 2-bit binary xx and 2-bit binary xx. So this is called as race condition. So this is not a problem of fork and join, but it is the problem with respect to the simulator. So parallel blocks will give rise to race conditions as shown in this example. Let's continue further with the special features of blocks. So the special features of blocks are nested blocks, named blocks, and disabling of named blocks. Now let us know in detail about these special features of blocks. First one, nested blocks. So nested blocks means, so we have come to know about a sequential block and a parallel block. So nesting of blocks means mixing both sequential and parallel blocks. Mixing or nothing but nesting both sequential and parallel blocks. So let us see an example here. Here we have a set of statements written within initial. Begin represents the sequential block. So within begin, we have written a statement x is equal to 1-bit binary 0, within which we have nested a parallel block where we have written two statements within fork and join. So this will constitute a parallel block. And again, we have written one more statement #20 w is equal to y comma x. So, and the sequential blocks ends here with the keyword end. So this is how we can nest both sequential and parallel blocks. So this is about nesting of sequential and parallel blocks. Now let us move on to the next special feature of the blocks, that is named blocks. What is this named blocks? So it is always possible to name either a sequential block or a parallel block. So the syntax is as follows. As we know that the sequential statements are enclosed in between begin and end, So we can give a name to the block where the begin keyword is followed by the name of the block with a colon. Similarly, we can give a name to the parallel block where the keyword fork is followed by colon followed by the name of the block. So this is how we can name a sequential block or a parallel block. So naming of the blocks has certain advantages. First one is can have local variables. Second one is are part of the design hierarchy. Third one is their local variables can be accessed using hierarchical names. And fourth one is named blocks can be disabled. So these are the advantages of named blocks. Let us understand this named blocks much better with an example further. So here we have chosen an example where module name is top. Keyword module is followed by the name of the module top. Module begins with the keyword initial, within which we have written a sequential set of statements written within the keywords begin and end. So here we can see that the keyword begin is followed by a colon, which is followed by the name of the block. So the sequential block is named as block 1. Within this block 1, within the sequential statement, so we can write certain set of statements. So as we came to know in the advantage that the variables, the local variables with respect to the named blocks, so can be assessed by a hierarchical name. So whenever we want to assess the variable I, which is mentioned within the sequential block 1, then we can mention the hierarchy, that is the module name is top dot followed by block 1 is the name of the block followed by the variable I. So this is how we can assess the variable from the named block. Similarly, we have one more block, that is parallel block, where statements are enclosed in between the keywords fork and join. So here the parallel block is named as block 2. So the name is followed by a colon. So the keyword fork followed by a colon. So we have the name of the block 2, where we have named the parallel block as block 2. Here we have declared a register by variable name I. So here also we can assess the variable, local variable that is declared in the parallel block by hierarchical referencing. So where this parallel block is belonging to the module name top dot the name of the parallel block, that is block 2 dot the name of the variable which we want to assess. So this is how we can access the local variables within the sequential and parallel block. So by hierarchical names. Let us move on to the next special feature of the blocks. So that is disabling of named blocks. The keyword used to disable the named blocks is disable, disable. So what is the action that will be performed by this disable keyword? This disable is similar to the break statement in C or C++, but disable will disable any named block, not just the innermost block. Means when we use the keyword disable, so it will disable any named block, but not just the innermost block. Let's understand this with an example. Here we have chosen an example module followed by the name of the module, find the true bit. Here we have a register that is 16-bit and the name is flag. That is, flag is a 16-bit register and I is declared as a integer. Here we have written a set of statements within the keyword initial construct. The initial loop begins with the keyword begin, where flag, which is a 16-bit register, is assigned with some 16-bit data here, and I is initialized to 0. Begin. We are beginning a sequential block here. So begin followed by the name of the block. The block is named as block 1. Within this, we have some set of statements. While I less than 16. So if this condition is satisfied, then only the statements within this while loop will be executed. So here we have initialized the value of I equal to 0. Since 0 is less than 16, then the loop will be, while loop will be entered. So begin indicates the beginning of the while loop when we have more than a single statement. If flag of I, so the value of I is 0. So if the value of I, that is, if flag I, flag of 0, the bit in flag bit, that is at the 0th position, if it is equal to 1, then this loop, the if loop, will be entered. So if we check the data what we have given to flag here, so it is equal to 0 initially when I is equal to 0, then the statement will not be encountered. So on. So the value of I will be incremented and then it will move on. So when we come to this bit, flag has a logic high value here. Then in that case, flag of I is equal to logic 1 and hence the statements within the if loop will be executed. So we have written a statement $display encountered true bit at the element number. So element number, so what's the position of this one bit in flag? So with the value of I. So once this condition becomes true, once it encounters a logic high bit, then this statement will be displayed. And so we have written a statement disable block 1. Block 1 is the name of the block. Now it will disable this while loop. So the disable keyword is going to disable the while loop. So further I is equal to I plus 1 will not be executed. So finally the block 1 will be disabled. So that is the while loop will be exited. And this end is for block 1 and this end is for the initial block. And the code ends with the keyword end module. So this is how, by using the keyword disable followed by the name of the block, so it is possible to disable the block, disable the named block especially. So if the blocks are not named, obviously it is not possible to disable the blocks. If and only if the blocks are named, then we can disable the named blocks. So let's continue. Let's look into the summary of the topics what we have discussed in this lecture. So we discussed about sequential and parallel, which are the two types of blocks. Sequential blocks are specified by the keywords begin and end, whereas parallel blocks are expressed by the keywords fork and join. Blocks can be nested and named. If a block is named, the execution of the block can be disabled from anywhere in the design by using the keyword disable. And also named blocks can be referenced by hierarchical names. So this is the summary of the topics what we have discussed in this lecture. Let us see few MCQs to understand whether we have understood the topics properly. The first question is, what are the keywords used to represent sequential blocks? Whether it is begin and end or fork and join. So as we know, sequential blocks are enclosed between the keywords begin and hence this is the right answer. Second question is, what are the keywords used to represent a parallel block? So, as a first option is begin end or fork and join. Yeah, we know that the parallel blocks are enclosed within the keywords fork and join. Third question, how are the statements executed inside the parallel block? Option A, in order, that is sequentially, or option B, concurrently. How are the statements executed in a parallel block? So the statements are executed concurrently in a parallel block. This is the right answer. So let us move on to the next MCQs. Fourth question is, the order of statements is not important in a parallel block, whether it is true or false. So obviously the order of statements is not important in a parallel block and hence it is true. Fifth question, only named blocks can be disabled. True or false? Obviously, it is always possible to disable only the named blocks. So if the blocks are not named, then it is not possible to disable the unnamed blocks. So these were the MCQs regarding this lecture. Hope you have understood the topics properly. Thank you for patient listening till the end of the lecture. So this is our team and these are the references which we have referred to prepare this presentation. Thank you. Let us meet in the next lecture.